Unit 4.5 Quantitative Data Analysis Techniques. Data preparation. Quantitative data analysis is the interpretation of numerical data collected through measurements and statistical analysis. It is used for numerical-based research such as collecting data rates or body weight, or results such as made baskets in game or practice. Benefits of using quantitative data analysis is that it allows us to use large amounts of data and sample sizes. This means that you can achieve more accurate results as the sample sizes are larger. Due to quantitative data analysis being objective as it just records data, it is also an accurate method of data research. Organizing data. The main method of analyzing and collecting data would be to find the range. This is the difference between the lowest and highest value. This is done in quantitative data as it clearly shows the difference between the biggest value and the smallest value, which makes it easier for the researcher to convey the data that they have collected. You calculate the range by subtracting the lowest value from the highest value. When using the gymnastic data from 2018, we can calculate the range of data for the standing vertical jump scores. This data had a max number of 56 centimeters and a minimal number of 15 centimeters. And by using these numbers, we take away the lowest value of 15 away from the highest of 56, which gives us an outcome of 41, which is the range. Rank order distribution. Rank order distribution means placing your data into an ordered list from the lowest to the highest in a single column, ensuring you include all the scores. Rank order distribution is used when the number of participants is less than or equal to 20. An example of rank order distribution would be when you have measured VO2 max across 10 subjects. You can rank the person with the lowest VO2 max at 1 next, and so on till 10. And so on till 10. Again, using the gymnastics data, the use of rank order distribution puts in a rank order which is easy for the researcher to visualize it if they want to find out the difference between someone's diastolic blood pressure. When converting the original data into rank order, the best way to do this is by using Excel, as it provides you with the right tools to simply put it into the correct order from smallest to largest number. Simple frequency distribution. Simple frequency distribution is when data is arranged in order based on its frequency of measure. An example would be if the gymnastics team competed in a number of events. We can then measure how often they used or competed in that routine by producing a graph or chart to help illustrate results. Simple frequency distribution is used when the number of participants is greater than 20, and when the range is less than or equal to 20. You use simple frequency distribution with a table that has two columns, one for raw data scores and one for frequency scores. The frequency column is the number of times that particular score was achieved. Using the scores from the Excel spreadsheet, we can score the values into table format. Therefore, picking out the exact values and tally them off the amount of times they appear in the series of numbers. After this, we calculate the frequency of the amount of time they appear, which is followed up by using these values to calculate the cumulative frequency. This involves counting the numbers up, but carrying the number over to correspond to the final outcome of what we got, 14. Group frequency distribution. Group frequency distribution is very similar to that of simple distribution. However, it uses a range of frequencies that are arranged into number order. Group frequency aligns the data into order across a range. This enables you to identify the key points of the data, as you can show a spike in data if the trend was to be shown. Grouped frequency distribution is useful when you have a lot of data. It allows you to plot data by frequency instead of using individual bars per data, as would be the case on a bar chart. In group frequency distribution, you often work with ranges greater than 21 and with more than 20 participants. When using group frequency distribution, the table has two columns, X and F. Except this time, the X column, or the group column, is for the group scores, and the F column is for the frequency. To keep your data on a single slide, you normally have between 10 and 20 groups of scores. The ideal number is 15. You need to decide on the interval size for each group. An example, diastolic blood pressure. The first step, the process, is to reorder the numbers into smallest to biggest, so it is clearer to see the number different. To ideally put them into a group that defines the number. Once this is done, the frequency is calculated. Quantitative Data Analysis Technique Part 2. Presenting data. The presentation of data is very important. It should be displayed in the most effective format. For instance, there is really no need to include more data. Tables of data should contain units and must have a suitable title. Graphs should also incorporate units and labels and contain titles. Any pictures, photographs, or diagrams, including graphs and pictograms, but not tables, are referred to as figures. The purpose of a graph is to help visually depict data and trends in data. The main requirements of graphs are scientific titles, axis labels, regular intervals, variables on correct axes, independent variables on x-axis, dependent variables on y-axis, there are many graphs a researcher can choose from. For example, there are pie charts, scatter plots, line graphs, bar charts, and box and whiskers graph. Scatter plot graph. A scatter plot is a graph of plotting points that show the relationship between two sets of data. Each point represents an individual score for both tests. A scatter graph can show a positive or negative correlation, or no correlation. There is a strong positive correlation between the sets of data if the line goes from the bottom left corner to the top right corner. And a weak positive correlation is when the plots go from the bottom left corner to the top right corner. However, the plots are much more spread out over a wider range. A strong negative correlation is when the points plotted go in a line from the top left corner to the bottom right corner. And a weak negative correlation is again when the plots are more spread out. The example shows the data results for the thigh girth and vertical jump. It shows there is no correlation between the data as they are spread out on the graph. Line graph. A line graph or a line chart is a graph which uses lines to connect individual data points that display quantitative continuous values. In this line graph you can see that the static sprints were faster than the flying sprints overall. Generally the data follows the same pattern. However, participant 6 is quicker at flying sprint than a static sprint, and participant 12 is significantly better at a static sprint than the rest of the group. The line graph is a good method of displaying the data because it easily shows the extent of the anomalies. Table. Tables are useful in representing the accurate data. They can display specific amounts rather than approximations that are more common in other charts. This allows people to understand the data in more detail, although they do take longer to interpret and understand. The data displayed shows the sex, size, side, statistic, sprint, standing, vertical jump, and flying sprint data, together with the mean, standard deviation, mode, maximal value, minimal value, and range. Bar graphs. A bar chart is a graph which uses parallel rectangular shapes to represent changes in the size, values, or rate of something, or to compare the amount of something relating to a number of different categories or groups.